let's discuss drilling, tapping, and reaming in the milling machine. Those are some things that we'll be called upon to do quite often in the machine shop trades. There's a couple of tips and tricks that I'll share with you about proper alignment of holes, how to chamfer the holes, proper tapping techniques to prolong those tap life. Nothing's worse than coming to work on Monday morning and breaking a tap off in a piece of material. Okay, so we'll show you some ins and outs. First though, before we get started, you can see that we have a little 60-degree pointed cone. We made this off of an end mill. If you break an end mill or find one that's been worn past the point of resharpening, send it into the grind shop and just have them grind a sharp 60-degree point on it. This is an invaluable little tool for picking up center punch marks, picking up a scribed line on a part that we want to use to drill and tap on. You're going to be called upon to do work for Farmer Brown down the street, automotive jobs, backyard home hobby jobs. It's not really necessary that we use the edge finder to precisely locate that hole within a 0.5 of an inch. If we have a scribed line or a center punch mark, we can simply use our pointed ground tool to come in and pick up the scribed line or pick up the center punch mark, and we're ready to drill, ream, tap, whatever the case may be. So it's a handy little tool to have in the top of your box when you're doing proverbial quick and dirty work that doesn't have to be really precise as it would be in an aerospace application. All right, let's go ahead and drill and tap some holes. The first one that we're going to do is a 10 by 32. So for most of you that have been in the automotive field, that's a pretty small tap, and you need to be careful. There's some tips and tricks that will show you how to keep from breaking that tap. But first, in order to determine the correct drill size, we've got a chart that's been provided by the folks at Cleveland Twist Drill, and it's a tap drill chart. If we go down the columns, it tells us the size of tap, the number of threads per inch. So we simply scan down until we come to a number 10, which is the size. The pitch is 32 threads per inch, and that tells us that we want to use a number 22 drill, and that is going to provide approximately 81% of the thread. Okay? So that's important. We'll also do a 1/4-20. While I'm busy setting up the mill, if you've got one of these charts, scan over it quickly and let me know what type of drill size we'll need to do a 1/4-20. Don't forget to wear your safety glasses. We don't want any drill shavings to come in. Always get in the habit, anytime that we drill a hole, whether it's for Farmer Brown or the folks at Boeing, we want to always use a good drilling practice by using the center drill first. The center drill is going to precisely locate the hole once we've made an adjustment on our XY axis on the mill. We just don't start with the drill and have it walk and wobble its way into the hole. All right? Make sure and adjust your quill handle where we're pulling down rather than pushing into the ram of the machine in case something slips or breaks on us. Okay, let's turn her on and we'll get started. We'll bring our center drill down. We can give it a little shot of WD-40. We're going to be tapping some aluminum. So we're going to drill down until we just start to pick up the chamfer. Right at that point. Okay, let's wipe it off and give you a little bit better view. We've used the center drill. We've drilled down and located precisely our hole. We've got a chamfer established that if we were to set our drill in the top, is going to guide our drill in place. We're going to drill a nice straight hole. Another trick that you can do if we're doing a hole pattern series, and we've got a lot of holes, we can simply drill deeper with the center drill as we go, and this automatically provides a chamfer for the screw or bolt that we're going to be threading in to that part. We'll do that on the 1/4-20 size. All right, we'll insert our number 22 drill in the chuck. Anytime that I put a drill in a chuck, I just like to give it a spin of my hand, making sure that we don't have any chips and that the drill is running true. Okay, we can see by spinning it by hand, it's running true. We're now ready to turn the machine on. Adjust our quill handle again. Nice smooth down pressure, clearing the chip. Continuing the down pressure, clearing the chip. Give ourselves a little shot of lube from time to time. Remember to turn your small drills fast. We're turning this drill at about 1750. It's going to drill a nice straight hole for us. Okay, that's to a depth of about 3/4 of an inch. We've got a neat little gizmo that we're going to share with you. This is called a tap guide. We've got a spring-loaded plunger here that guides over the top of our tap. It's got a cone on one end and then a point on the other to go with the different types of taps that we're going to be using. We'll look at the end of the 1032 tap and you can see the cone on the end of it. The tap guide simply goes over the top of it and with spring pressure aligns it and keeps it straight during the tapping operation. So this is an invaluable tool. It allows you to tap very fine holes and keep them nice and straight. We'll take our tap, give it a shot of whatever lubricant we're using, whether it's steel or aluminum. Insert our tap guide in the drill chuck. We're going to lower the bed. We've got some clearance there, okay. Now we're going to lower the quill and watch closely. As we bring the quill down, we're compressing the spring in the tap guide. So we're preloading the tap. Another shot of lube. Okay, and then we simply, with 2 fingers, very gently advance the tap into the workpiece. 4 or 5 rotations, stop. Back it up a rotation. We're clearing the chips at that point. If we were to sit there and just keep on twisting, depending upon the type of material and the lubricant that we're using, we're going to fill that tap up, create a lot of friction and tension on the tap, and invariably break the tap off before we get the hole tapped. When you break a tap off, it's really a pain in the tail, so try not to do it. Taps are expensive, but more importantly, you're going to waste a lot of time trying to get that broken tap out of the hole. So continue to advance the tap, clearing chips from time to time, simply by reversing the direction of our tap. Okay, when we've gotten to the bottom of our hole, simply stop, reverse the tap, till we come up against our spring-loaded tap guide. And at that point, I simply release the quill, retract the tap guide, and manually extract the tap from the hole. You can have a couple of threads there to take off. Okay. Now we've got a tapped hole. In that tapping process, because we didn't run our center drill in very deep, just enough to pilot our drill off of, we've got a little raised burr around the top of that hole. So to make the job look nice and clean, we're going to put in a little counter bore or chamfer tool. This particular one is an 82 degree. We'll fire up the mill and we'll just take that little thread burr off of the top. I usually just start the machine, turn it on, let it get up to speed, and then turn it off. Bring it down very slowly, and we now create a chamfer around the top of that tapped hole. This allows our screw or bolt to go into the hole easily. Now let's move on to a little bit larger size and show you again another trick. It's going to be a 1/4-20. So we're going to want to bring the center drill down a little bit deeper, establishing a larger chamfer in order to pilot our drill off of. Okay? For those of you that had a tap and drill chart, what is the correct size of drill that we need to use for a 1/4-20? You guessed it, a number 7. It's a cobalt drill that we've installed. We'll give it a little shot of lube here. Clear your chip. Okay, for this next move, make sure that we've got all the chips out of the hole. If you get some buried down in the bottom, simply take your air hose, give it a little shot of air to clear those chips out. We can use the tap guide again, which is really a preferred method if we have thin material that we're going to be drilling and tapping through. Here's a little trick that you can use in essence to power tap. All right, a little bit of finesse is involved. Go ahead and give the drill a little bit of lube. this point, we're going to turn the machine on and then turn it off. And as our tap is slowing down, we're going to advance the tap via the quill into the hole, okay? We don't want to leave it on and run at 1750 because as soon as that tap grabs, it's going to feed itself into the hole, and presto changeo, we're going to break a tap in about a half a nanosecond, okay? So we're simply turning the machine on, turning it off, and as the spindle is coming down to a slow or coming to a stop, we're going to advance the tap into the hole. Watch closely. Make sure that you have plenty of lube on whatever material you're using. Okay, we've turned it on, we've shut it off, and as it's starting to slow down, we're simply going to advance the tap into the hole. This is a good way to start and align a tap as well, but we only want to do it on sizes 1/4 inch and larger, okay? We don't want to run the risk of using it in a 256, a 6x48, or a 1032, because if something grabs, if the tap's a little bit dull, if we don't have enough cutting fluid on the tap, we'll snap it off just that quick, and we're going, oh great, there we go again. So once we've got the tap in the hole this way, the tap is stopped, we can simply back the tap off, break those chips, and continue by hand with our chuck, advancing the tap into the hole manually. Clear our chip from time to time, all the way to the bottom of our hole or through the thin piece of material that we may be tapping. We can loosen the chuck, we can have our tap exposed, we can now insert a tap handle on the top of the tap, finish off the hole. We've bottomed out, simply reverse the tap, and we're ready to go, okay? You can power tap in back gear, but you really need to be on the ball. You don't want to be doing it in a bottomed hole anywhere. It would simply be a through hole that we would tap in forward and reverse. But I really think that's a little bit risky for what you're doing. I think for the little bit extra time that it takes and eliminating the risk of breaking a tap, wrecking a job, you're better off using the two methods that we've just shown you. All right, let's blow the chips out of the hole. We've got a beautifully tapped hole there. We'll go ahead and run our countersink down. But just chamfer that hole. Again, just turn the machine on, turn it off, bring it down and let it cut a beautiful chamfer countersink around the top of our tapped hole. All right, now let's say that we have a series of holes that we just need to drill through. Clearance holes for a bolt, a screw, a pin, whatever we want to do, and we want to be a nice, clean, professional looking job. We want to have a uniform chamfer all the way around the hole. We can do this. Another neat little trick. Simply install our center drill. Center drill down. We're going to drill a little bit larger hole this time. Okay, if we look closely, you can see that we've raised a little bit of a burr around the top of that hole. We've got a series of holes, maybe 6, 8, 10, 12 holes in the parts that we're drilling. We want to have a uniform chamfer or countersink around the top of those holes. So in order to establish that uniformity, here's a neat little trick to keep in mind. Once we've drilled our holes, we've established the hole pattern, we're going to come back and countersink all of those holes with the same depth. Okay, we're simply going to bring our countersink down against the hole until it bottoms out. We're going to go up to the quill stop. We're going to use the quill stop in order to establish the same depth on all of our holes. Advance the stop up to the quill with the lock nut, and we'll say, all right, we want to take 15-20 thousandths off around that part. With it locked in position, we're simply going to loosen the lock ring, back it off a little bit, lower the quill stop 20 thousandths of an inch, hold it in place, bring our lock nut up to the top, retract our quill, And now watch what happens as we lower the quill back down to the workpiece. I'll try and give you a real close-up view so you can see the chamfer take place. Turn your machine on. Bring it down. We've got a perfectly uniform chamfer all the way around the hole, and every hole that we do in our series of holes on the part now is going to have the exact same chamfer on it. Really adds professionalism to the part. The guy goes, yeah buddy, this machine shop's on the ball. Look at the way they chamfer the holes, okay? It's a small thing, but it's a small thing that's important in the finished application that you're dealing with. When the customer comes in to pick up his or her parts, first impressions are vitally important. They want to look at the part and go, whoa, that's better than I anticipated. And if they walk away with that feeling, you know you've got them for a repeat customer. All right, now let's go to the next phase, and that is drilling and reaming a hole. Oftentimes, if we're going to use a dowel pin or we have a particular part that needs to mate, we need a very precise hole. We can drill reasonably precise, but when we need it really precise, we need to ream the hole. Okay, and reamed holes are going to be plus or minus a couple of tenths, depending upon the straightness, the sharpness of the reamer, and how we apply them. So here's the reaming process. Again, we're going to center drill. Make that a habit that we never lose, is drilling with a center drill first. We always start the hole with the center drill. Okay, we're going to ream a 9/32 hole, and anytime that we ream, I like to drill as close as I can to that hole within, let's say, 10/12 thousandths of an inch, and then we'll ream that last 10 or 12 thousandths, all right? So 9/32 is 281 thousandths. We're going to go ahead and drill that out with about a 270 thousandths drill. So that's going to give us 10/11 thousandths, depending upon the finished size of the hole after we drill it. Get into practice, give our drill chuck a spin. Once we've installed our drill, make sure it's running true. Okay, we'll drill to our desired depth, and now we're going to install our reamer. We don't ream at the same speed that we drill. If we're to do that, the guy at the reamer shop's going to just be smiling all the way to the bank, okay? We always ream in back gear, so we're going to turn that reamer really slow, use a lot of fluid. Probably want to use a fluid that's got a little heavier viscosity than the WD-40, okay? A good sulfur-based oil, a good thick cutting lubricant is a much better reaming. We're going to go ahead and shift our machine into back gear. Grab our can of lube, and if we're doing reaming a blind hole, I like just filling that blind hole up with our cutting fluid. Okay, again, we're going to be turning in back gear. Make sure that our chuck is secure and tight. Get our quill to the proper location. We can even give our reamer a little shot of oil there. Can't use too much fluid in a reaming application. All right, we're going to ream down a little bit, stop and clear the chip. Put it back into the hole. We don't want to load that reamer up. Then it'll freeze and stick in the hole. Okay. You can see we're pulling a pretty good chip. We can stop it. We can take our fingers, clear the chip. You can use a little bit of air on it. Just remember to be careful. We don't reach up and grab those chips while the cutter is running. Ream down to the bottom of the hole, slowly retract, we're ready to go. Okay. Always have plastic protective tubes for your reamers. A reamer is a very, very delicate cutting tool, and they're often going to come with a nice little plastic tool holder. Okay, make sure when you're done, take a little bit extra time, insert it back in its tool holder. Just don't set it on the bench and let it clatter around with the rest of our cutters. And now we're ready to inspect our hole. Take the air hose, get rid of our excess fluids. Okay, we've now got a precision reamed hole at 9/32 of an inch in diameter. We want to come back with our countersink now. Remember, anytime we put the machine into back gear, once we switch to direct drive, we need to reach up with our wrench or hand and manually turn that spindle, making sure that the gears have meshed properly before we turn the machine on. Adjust our quill handle, and now we're going to come down and just countersink the top of that hole. Okay, there we go. Voila, finished job. All right, so that covers some of the ins and outs of drilling, tapping, and reaming. Now we've got a special problem to attack or address. Let's take a look at drilling a hole on an angled surface. This can be a real chore. For those of you that have played with a drill press in high school shop or something and didn't have the part absolutely perpendicular or had an oddball part to drill, drilling it on an angle without knowing some tricks can really be frustrating. Okay, we're going to install that in the mill vise. We're going to find the approximate center. Let's turn that around. Let's go ahead and turn the block around a little bit. I think it's going to give you a better view on camera there. Okay, we'll go ahead and locate a hole right there. Now, here's the way that Farmer Brown would probably try and do it, and you tell me if you would feel comfortable with these results. All right, we've got an angled surface that we're trying to drill. If we take just an ordinary drill and put it in the machine, watch the point of the drill and see how it tries to walk off of that surface. See, that's not going to be a very precise hole, is it? We're just going to really have a problem getting that. If we needed to tap over the top of it, we're going to be in trouble. Now, if we use a center drill, the center drill is going to help a little bit, depending upon the steepness of the angle, okay? So let's see what a center drill will do in trying to clean up that hole. Okay, if we're real careful, center drill is plenty rigid. We can go ahead and get that started in that fashion, okay? Now the other important thing that we're going to deal with, we've center drilled the hole, but if we look closely, the chamfer in the hole due to the angle is like this. So again, that drill is going to want to walk a little bit. So we're either going to need to make a larger center drilled hole so it will align itself uniformly, or we can use a method of called spot facing this area with an end mill in order to make it flat. So in order to do that, before we would drill the hole, let's go ahead and remove our chuck. All right, we're going to insert a 3/8 collet. Be using a 2-flute 3/8 end mill, center cutting, to come in and spot face our hole location. This is going to give us a flat that we can later come back and center drill on, and then go ahead and drill and tap a hole should we so desire. Okay, there we go. We've located a flat on the top. We can now come back with the center drill, pick up that hole, drill and tap to whatever depth we want. And the hole is perfectly parallel to whatever surface that we're machining. Okay, we can install our larger drill now. And presto changeo, we're done. Okay? So that's a neat little tip to keep in your bag of Indian tricks anytime that we have an angled surface that we need to drill a hole in. Okay, now let's take a look at doing basically that same thing on a round part where the hole is offset from the center. That's another thing. If we need to drive a retaining pin or something into a part that is cylindrical, we're going to have a real tough time with accurate hole location unless we go in and spot face that hole. Okay, if you've got a good assortment of smaller end mills, the same thing applies. We can use a smaller end mill so we don't have to create this large flat. All right, it's always advisable when we're spot facing that we use that center cutting end mill. Most all of your 2-flute end mills are going to be a center cutting, plunge cutting end mill. You'll get that in a 4-flute as well. You're just going to have to specify it when you order that milling cutter from your local supply house. You can get a 4-flute either way, center cutting or non-center cutting. Always use them in the collet or a tool holder. There's special applications where we can use an end mill in the chuck, but that's just for going in and bringing a hole up to size with the end mill, and there's certain applications there that we need to keep in mind. We don't want a heavy removal of material. We're just bringing something to size, and again, we would turn that into back gear and feed it really slow. Okay, now let's pretend we're going to put a hole in this part off center. So in this application, if we were to look at it from the end, you'd see we have quite a bit of offset with the hole, and this would be extremely difficult to do without the aid of an end mill in a spot facing application. So watch closely. We're going to put a little spot face on the top of our part, go in and center drill it, and then drill an 80 thousandths hole into our round cylindrical part. Okay, we just want to bring enough to allow our center drill to come in and cut. Okay, we'll install our center drill. Make sure that when we put a center drill in now that we push it up against the plate and then pull it down 30-40 thousandths so we're not compressing the plate on top of our center drill and dulling it. Okay, we're just going to come in and center drill our hole down to where we've just got a slight chamfer on the top, a little bit larger than the intended drill that we plan on using. And go ahead and insert our 80 thousandths drill. Okay, and now we'll come in for final hole size. Okay, anytime when you're dealing with a really small drill, clear the chips frequently, turn it at high RPM. Use a good lubricant depending upon the material that you're drilling. Okay, now as we get ready to break through on the other side, it requires a little bit of feel on the machine operator's part. When that drill starts to break through, we just don't bury the quill through it. We let it cut very slowly until it completely penetrates the other side. That way we don't break it off. Okay, there we go. All right, there we've performed a very difficult task. If you didn't know the secret, you'd be struggling for quite a while in order to get that hole straight through our particular part. We spot faced the top of our hole, we center drilled and then went in with our 80 thousandths diameter hole, clear through the little nozzle, if you will. Now, in order to deburr the back side of this, you can simply do it with a file or take a little 3-cornered scraper and go ahead and clean the burr off of it, and that part's ready to go in the finished basket. Our next operation involves locating the center of our block, drilling a 1/2 inch hole, and then with an edge finder going into each 4 corners of the block, drilling and reaming a hole for a 1/4 inch dowel pin. When we're working along that line, I think it's a good idea to use a magic marker or a Sharpie felt pen and write some dimensions on our block so we're not constantly having to go back to the calculator or figure them mentally. Another good idea is to make a little diagram, and you'll have a print showing you the dimensions on this specific block. Write those dimensions down on a 3x5 card, set it next to the mill for a handy reference. It keeps you from running back and forth to the bench to check dimensions. So we're going to take our felt pen, we're going to mark some locations here. From each corner, we're going to come in 625 thousandths. That's the location of a hole that we're going to drill and ream to 1/4 inch. Those holes will be a depth of a 1/2 inch. Next, we're going to locate the center of our block. We're going to drill a hole a 1/2 inch clear through the block. Then we're going to come back and pick that up a little bit later. So with those markers on our block, let's install our drill chuck and the edge finder and get to work. Okay, don't forget in this operation to add your 100 thousandths for the offset in the edge finder. You'll notice that I've written the 1/2 dimensions down on our part in those 2 directions. Again, we have a simple reference to work from. Let's get started. Okay, very gently bring the edge finder up to contact the work until it offsets. We'll retract it just a little bit. Zero our x-axis, 2 inches and 50 thou. Okay, we can lock our table in at that point. Now we're going to work off of the y-axis. One inch 412.5. Okay, we've now located the center of our block. It's time to drill our 1/2 inch hole. Remember to be aware of the position of the quill handle when we get ready to drill. We want to be pulling down, not pushing away in case it slips. Always center drill our hole. Come in with our pilot drill. Take the time to clear the chip now. Simply don't bury the drill in the part. We want a nice straight hole. Okay, we're now ready for our 1/2 inch drill. We're going to slow the speed down just a little bit. I'm going to go to 660. Okay, never grab those chips while the drill's turning. Always stop, remove the drill from the chuck, then remove those scary chips. We don't want to be calling you stub at the annual picnic. All right, we've located our hole in the center. Now it's time to put our edge finder back in, but before we do that, you can see that we've raised a burr around the top of our hole. So let's grab our countersink and we'll go ahead and just break the edge off. Okay, there we go. Got a nice burr-free hole at that stage of the game. Okay, now once you've been machining on a part, if you're going to be using the edge finder again, take your paper towel, wipe all the chips and debris off of our block so they don't interfere with our edge finder reading. Remember, 625 thousandths from each side of the part. We'll start in this corner first. All right, for those of you that don't have a digital readout, it's real good practice now. Loosen, lock the table down once our edge finders come in contact. Loosen the lock nut. We're going to zero out our dial and advance 625 thousandths plus the 100 for the edge finder. We're going to work over to the other side of our part. And repeat the process. Forget, we want an accurate zero when we establish our edge. Okay, we'll go back to our center drill. Remember, when we're going to ream with a 1/4 inch hole, we want to drill as close as possible, leaving a few thousandths for the reamer to clean up the hole and bring it to size. We're going to be reaming with a 1/4 inch reamer. We've chosen the letter C drill out of our drill index, which measures 242 thousandths. That'll leave us roughly 8 thousandths for the reaming process. Now at this stage of the game, we're going to drill the hole a 1/2 inch deep. We're going to leave the chuck and table settings the same, so we want to bottom the drill out in our Albrecht chuck. Adjust our quill travel. When we start cutting full diameter on the drill, you'll notice the drill's got a cone shaped on the end of it, 118-degree split point. As soon as we get up to the full diameter of the edge, that's when the depth of our hole starts. Okay? So watch closely now. We're going to come in contact with our center drilled hole right at the point that we're drilling full diameter. Go ahead and shut the machine off. Bring our drill down. And we can raise our quill stop. At this point, okay? You can either use a 1/2 inch spacer block, a 1/2 inch dowel pin, works really fine. Simply loosen our lock ring. Roll that down. We can even use the 1/2 inch shank on a mill cutter if we want to use that as a spacer. Simply going to insert it between our stop. Screw it up till it contacts. Bring our lock ring up. Presto changeo, we've now set it for a 1/2 inch within just a few thousandths. Another neat little tip and trick that you can use. They also make gauge blocks for that. In your spare time, if you're drilling a lot of holes to specific depths, go ahead and machine up little aluminum blocks or steel blocks that you can use as spacers between your quill stop. All right, so let's retract the drill now. Go ahead and drill our part to final depth. Make sure and clear the chips from time to time. There we are, we're up against our stop. Okay, we're now going to insert our reamer. Remember, when we ream a hole, we need to slow down the RPM. There's no way that we can ream this hole at the same speed that we drilled it. We'll take a little bit of thick sulfur cutting oil, fill our hole up, shift our machine into back gear. We're now ready to ream our hole. Make sure and clear the chips. If they start to get a buildup, we're only removing 8 thousandths. Bring the reamer down until it bottoms in the hole. Treat your reamers as you would the rest of your tools, very, very gently. Okay, we now have a reamed hole that's a 1/2 inch deep. We're now going to move on to our next hole. Keep in mind, we've already figured our 625 dimension from this side of the tool. So now, if we want to get fancy, we can get out our calculator, measure the width of the block, subtract 625 away from it, and advance in the y-axis over to the next hole. Or if we feel we need a little more practice with the edge finder, slip the edge finder in, come over off of this face, contact, come in 625 thousandths for the location. The reason we're having you to do this is to get the feel for using the edge finder. It's a very, very important tool. It's a very sensitive tool. We need to exercise a little bit of finesse when using the edge finder for precise location of our holes. I'll go ahead and finish up the holes. We've shown you how to do the first one, and I'll join you in just a minute. All right, I've finished up our 4th hole. Now let's go ahead and put a chamfer on the tops of those holes because they're just razor sharp right now, and this will also allow us to drive the dowel pin in a little bit easier if it's got kind of a chamfer or guide. Remember the little tip we showed you earlier about using the countersink, bringing it down in contact with the hole, setting our quill stop, and then backing it off so we can cut uniform depths in all 4 holes. Now, for those of you that have done the math, this is going to work out really well. We should have been keeping track of the number of thousandths that we needed to move from hole to hole to hole on the X and Y axis. Those should be written down on a little notepad somewhere. If they're not, grab the calculator, a sharp pencil, and make those necessary calculations so we can just adjust the table around to 4 different positions while we've made this adjustment in our countersink without having to use the edge finder again. Okay, we've got a 20 thousandths adjustment. Let's go ahead and chamfer our holes now. That's what the first one looks like. Now we're going to move to the second one. With all the handwork that you're doing, the next time the digital salesman enters the shop, you're probably going to buy one of those digital readouts. For this type of work, it's a real lifesaver. All right, with our center hole located, our 4 holes for the dowel pins drilled, reamed, and chamfered, it's now time to clean the block off, turn it on edge, and let's practice some more drilling and tapping. Alright, our next operation involves drilling and tapping 3 holes. The tools you're going to need to perform these operations are a center drill, a number 7 drill, a countersink, a 1/4-20 tap, and the edge finder. We're going to locate the holes 1 inch in, centered in the width of our block. So if you don't have those measurements committed to memory, grab the dial calipers, divide them by 2. Don't forget to add the 100,000ths for the edge finder. And now let's begin. Okay, remember we showed you different methods of tapping a hole in the mill. You can use a tap guide, which we've inserted in the chuck now, or if you don't have a tap guide, simply insert the tap in the chuck, turn the machine on and off, and as the tap starts to slow down, feed it by hand from the quill into the workpiece. Remember to keep it rotating slowly. We don't want to break the tap off. We don't want to have it bottoming in the hole and then proceed to finish the hole by hand, either by turning the chuck or by removing it and inserting a tap handle. We'll use a little bit of WD-40. We'll show you both methods just as a refresher course. Very gently rotate the tap 3 or 4 revolutions till you feel the tap start to get tight. Reverse directions, break the chip hold. Continue. 1/4-20 taps, pretty tough, but you can break them if you get a little heavy-handed. Take your time. Remember, we want to feel each operation that we do as a machinist. Okay, there's one done. Let's go ahead and advance over to the next hole. Okay, we're going to do this one with the tap guide as well, and then we'll finish up on the last one using the drill chuck as the driver for the tap. Little tap handle I'm using is made by the folks at Starrett. They're kind of expensive, but believe me, they are the finest little tap handle going. It's just a neat thing to have in your toolbox. I get a lot of pride and satisfaction out of owning and looking at well-designed tools, and I'm sure you do the same. Nothing's worse than a piece of imported junk that was simply cast and never finished off. They had no pride in the finished product. Something you simply hide in the toolbox rather than show it to your friends when they come over for a visit. Okay, now let's remove the tap guide. We're going to insert the tap in the chuck. We're going to advance down to the next hole. Clear the chips, give it a shot of WD-40, and watch closely now. We're going to turn the machine on, let it slow down a little bit, and then advance the tap into the hole. You can manually turn the chuck now, backing it out, clearing the chip as we go. The chuck's holding our tap in perfect alignment and concentricity with the hole. When you feel the tap start to get tight, it usually means we're bottomed out against the hole. Simply exert a tiny amount of pressure upward on the quill arm and remove the tap. And there we have it, another tapped 1/4-20 hole. Now let's go ahead and install our countersink and go back across those holes and give a countersink to each of those threads so the bolt or screw starts smoothly. Okay, remember, we'll clear our chip out of the way. We'll bring our countersink down in contact with the hole. We're going to use our quill stop. And we're going to back it out 30 thousandths this time. We're going to go across and chamfer all of those holes. Okay, now our block's starting to take shape. We've got 3 properly tapped holes. We've used the countersink. They should all be of uniform depth and diameter. But before we move on to the next phase, I have a couple of questions for you. How many of you, when you had the center drill in, after center drilling the first hole, automatically went to the second and then the third hole, inserted our drill, reverse directions, drilling all 3 holes simultaneously, and then started the tapping operation? If you did, take your hat off. You're starting to catch on to the idea of a production method of making parts. This drilling application, there was no reason why we had to drill, center drill, drill, and tap each hole one at a time. While we've got the tool in, the holes were spaced close enough that we could simply advance the table 5 revolutions. Remember, they're on 1-inch centers. Center drill the next hole, 5 more revolutions, center drill that hole, and then take up the backlash. Reverse the procedure, drilling our hole to depth, come back across and tap them. That's the correct way to do it. All right, let's grab our practice block and get ready to start our project. You'll be supplied with a rough cut piece of material. You're going to need to prep the stock like we showed you earlier. And let's go over that again. You can see we've got big burrs on it. Simply take our file. We're going to remove those burrs. Is your file at about 45 degrees to the workpiece. We're going to go over all of the cornered surfaces, removing a burr so it doesn't affect the location of our part when we put it in the vise. See, a lot of very skilled people spend hours on a part and then neglect to remove a burr, clear the chips. All of those hard hours are for naught at that stage of the game when we wreck a part. So be very conscientious in keeping everything squeaky clean. All of our edges burred while we're machining on a part until final inspection. All right. I think that pretty well covers it. We're going to go ahead and take a rag now and wipe that part off, getting all the little filings and chips off of it. Okay, we're going to go over our vise jaws, making sure that they're clean and chip free. Grab a felt pen or a little Sharpie marker. Let's take and put an X on the front face of our part, just as a reminder as to which face goes up against the master jaw in our vise. We're going to take our block, push it up against there, take our round piece of bar stock, put it in behind the part. This is going to force it up against the jaw, which is our master jaw. With everything nice and tight on the vise, we're ready to install our collet. We're going to surface the top edge of the part with a 3/4 inch solid carbide end mill. All right, we made a speed change. We're going to turn the 3/4 cutter at around 1750. We're going to really put some horsepower to it this time in our squaring operation. Bring the cutter down in contact with the work. We're going to lock the quill in place. We're going to take about a 20 thousandths cut in order to prep this edge. Don't forget to don your safety glasses. We're going to give the cutter a little shot of WD-40. We'll raise the knee 20 thousandths. Take our first cut. All right, that bulked off a lot of our material. Now let's go back. Since we can use this as a finished edge now, we'll take another 10 thousandths off. We'll slow our feed rate down a little bit, make a finished pass across our part. Remember to have a smooth cranking of the hand wheel. We want a nice finish. We don't want to have a jerky transition as we run the cutter across our part. Take the cutter all the way to the end, index over. Again, nice smooth movements. Give ourselves a shot of WD-40. This will give us a nice finished pass across the top of our workpiece. Go ahead and shut our machine down, loosen the vise. Grab a paper towel and we're ready for a little cleanup. Wipe the chips off of our part, clean our vise jaws out. It's real important now that we start this squaring operation that our vise jaws are absolutely, positively, spotlessly clean and free of any chip or debris that may affect the accuracy of our part. Grab our file and we're going to break that sharp edge across our part. Use our rag, get all the chips off. Okay, we're going to put the same face up against our master jaw now. The area that we just machined goes on the bottom. We're now going to cut a parallel surface. Install your block. We're going to take our two fingers, we're going to press down on the block. Tighten our jaw. We'll come back, let's take another 20 thousandths pass. Okay, now we've created two parallel surfaces. We can remove our block, and at this stage of the game we've got a couple of options. We can continue the squaring operation, or we can go ahead and cut our part to dimension at this time. In order to save time, let's do that. Using our dial calipers, we're going to measure the width of the part. We get 2 inches 649 thousandths. So our specification calls out for 2 inches 625, or 2 5/8 inches. So we're going to need to take 24 thousandths off of the part. This time we're going to insert it back in the vise. Remember, this is our final pass, so we don't want to muck it up by having a chip or any debris in. Put our bar in the back, cinch our vise down, turn our machine on. We're going to elevate the table on the Z-axis 24 thousandths. Going to lock the knee in at this time. We're going to take a nice finish pass across our workpiece, so slow your feed rate down just a little bit. Okay, our part is now dimensioned in one direction. Go ahead and wipe it off. We'll grab our dial calipers and we'll check it for size. Okay, exactly 2 inches, 625 thousandths, give or take a couple of tenths. Okay, we're going to keep our reference now. We're going to run our file across our part, taking away those sharp edges, removing any burr that may have been caused during that machining operation. And wipe our part off, keeping it spotlessly clean. Go back and clean our vise jaws out again. We're going to grab a couple of parallels at this time. Support our workpiece as we begin another fly cutting operation. Remember the little tip and trick about spraying a shot of WD-40 or any kind of spray oil on the inside of your vise jaws when we put the parallel in place. We just friction fit and hold the parallel up against the vise jaw, eliminating the possibility of any chips getting in and around or underneath our parallels. Run our hand over the top of our block, making sure we've got a nice burr-free surface that we're going to set down atop the parallels. Remember, this is the surface that we had clamped up against our master jaw. So we're going to reference that off of our parallels now. We're going to go ahead and extend, push our parallels back, center the block in the vise. We'll go ahead and fly cut to dimension. Now remember, with our left hand, we're going to take and push down on the block as we gently close the vise, snug it down. Keep our hand on top of the block as we loosen the vise to detect any misalignment that may occur during the clamping process. Everything feels nice and tight. We'll go ahead and remove our cutter and replace it with the fly cutter. Okay, now in the fly cutting operation, we talked earlier about using the power feed. This is a real good time when you're fly cutting to go ahead and kick back a little bit, concentrate on the next step that we need to machine after we fly cut our surfaces and bring the part to dimension. So we'll go ahead and take advantage of the power feed, give our arm a rest. You want to center the fly cutter over the part so we get a nice uniform facing cut. Let's go ahead and raise the bed a little bit so we don't have the spindle sticking down quite so far. Okay, we're going to go ahead and bring our cutter down, come in contact with our work, and we're going to lower the bed an additional 5/1000ths. We need to slow our speed down. We were turning the 3/4 inch solid carbide end mill at 1750. Now we're using a 4.5 inch diameter fly cutter. So we're going to shift gears and turn that at 660 RPM. Okay, we're going to back our cutter away from the workpiece just a little bit. Turn the machine on. Advance the cutter. Raise the bed to the point that we just come in contact with our workpiece. Now let's take a look at the servo feed, take a little refresher course on that. Got our power feed, switches on the bottom. We're going to turn it on. Our little knob that you see here indicates the direction that the table will move when under power. This direction allows the table to move from right to left. This direction allows the table to move from left to right. So we're going to move from right to left on the first pass. We've come in contact with the workpiece, with the fly cutter. Let's take around a 25, let's go a 20/1000 cut on the first pass with the fly cutter. Raise the knee, lock the gib down, give the top of our part in the fly cutter a little shot of lube. We'll go ahead and advance the material into the cutter. Okay, you can see the feed rate that we're turning. Again, this is infinitely adjustable. Our servo feed is on a rheostat, so we've got plenty of adjustment there. Give ourselves a little shot of WD-40. With a little bit of practice, you should be able to advance the cutter across the workpiece almost as smooth and uniformly as our servo feed. All right, once the cutter has cleared the workpiece, go ahead and return it back to 0, stop it, change our feed direction lever back to neutral, and then manually advance the cutter away from the workpiece, turn our machine off, and we can inspect our part. We've got a nice mirror finish. On the top, we're going to go ahead and remove the burr on both sides of the part, flip it over, surface that side of the part, check it for thickness, and adjust and machine to dimension. That dimension is 1 inch 200 thousandths. Again, get in the habit of wiping the heel of our hand all around the part, detecting any burr that may be present. Take our paper towel, clean the tops of our parallels off and the vice jaw. Now it's a good idea at this point to give us a general idea of how much we can take on that second pass. Just go ahead and grab our dial indicator, our dial calipers, excuse me. And we're going to go ahead and take a rough measurement. We've got 1 inch 237.5 thousandths. So if we were to take 30 thousandths off in this next pass, that's going to allow us a finished pass of somewhere in the neighborhood of 5 to 6 thousandths. We'll go ahead and take 30 off, pull the part out, check it for dimension, and then take our final pass to bring us into specification. Again, push down on the part on top of the parallels with the left hand, gently close the vise tight, back it off, feel for any shifting or disruption. We want to make sure that that part stays flat on top of our parallels. All right, we'll fire up the machine again. We're going to reverse direction on the power feed. We're going to raise the knee an additional 30 thousandths. Lock the gib. Give our part a shot of WD-40, and let's advance the cutter. So you can see how efficiently a fly cutter is capable of surfacing our workpiece. If we were to take the 3/4 inch cutter, we're going to be running back and forth across that. It's going to look like a maze with the cutter tracks across the top. All right, once the cutter has cleared the workpiece, we can shut off our power feed, feed selector direction to neutral, manually advance the cutter away from the part, shut our machine down. We're going to pull the part off, burr it, and check it for dimension before we make our final finished pass. All right, the part's starting to look pretty snazzy now. Got some beautiful finishes on our fly cutting. Got a good sharp cutter. We can just use that as a signal mirror and call the cavalry from the other side of the valley. All right, let's take our dial calipers and check for dimension. Okay, we're at 1 inch, 209 thousandths. So we can go ahead and take that 9 thousandths in one more pass, and that'll bring us within specification on that dimension. And this has allowed us to square the part in 2 directions. Okay, remember we hold the part down, snug our vise up, back it off, tighten it up again. Go ahead and turn our machine on. We're going to raise the bed 9 thousandths of an inch. Lock our gib down. Run over to the power feed and let's go. Remember, if this were a production line, we would simply go through all of our blocks and resurface and do everything while the machine is set. It's very important when we do production that we try and take advantage of as many steps as we can simultaneously. We don't want to be adjusting the cutter for each and every part that we do. Start an assembly line, continue all the way through, finishing that operation, index all the parts over, surface them all to thickness at that time. All right, let's pull our part out, check it for final dimension, and then proceed with cutting the block to length. If you establish good work habits early on in your machining career, you're going to be really hard to break. Always get in the habit of burring the parts. Don't get in a hurry. Don't rush the job. When we start rushing, that's when mistakes happen. It's really hard to put the metal back on. You see how easy it comes off, but it can be a real pain in the tail to put it back on if we make the proverbial sausage too short. All right, that last pass was 9 thousandths of an inch and should put us at exactly 1 inch 200 thousandths. We're actually around 1 inch 200 thousandths and maybe a tenth or two. So again, within specification. Now, let's go ahead and cut our block to length. We'll wipe our parallels out again. Another thing that can occur when you get a little sloppy and you leave a chip in the vise, especially when you're working with aluminum or parts that have been ground, is that chip will get between the vise jaw and the workpiece, and when we compress the vise, it embeds the chip into the side of the part. If these parts were cosmetic and they were going to go to anodizing when we're done, we want as nice and smooth and uniform a finish as possible, because once we put the anodizing on, those nicks and dinks are going to show up like a sore thumb. Right, we're going to push our parallels back a little bit so we can protrude a little bit of our part from the vise jaw. Clamp it down. We're going to go ahead and go from a fly cutter back to an end mill and face mill the ends of our part. Got our cutter choked up pretty far. We'll go ahead and center our cutter with the quill, lock it down. We're going to speed up the RPM a little bit on this one to around 1115. Rough that in the conventional milling form. We'll come back across it in a climb cut. And then lock our table down. Going to take 10 thousandths in this pass. Then come across with about 2 thousandths for a finish cut. Loosen the gib. Make our adjustment. Lock the gib down. We're ready for a final pass. Nice and smooth and consistent. We crank the hand wheel on the y-axis. We want a smooth, uninterrupted cut. Alright, get our cutter out from around the part, burr it, take a roughing pass, a measurement. We'll have cut our block to length. That dimension we want to cut it to is 3 inches 900 thousandths on the money. You're going to be graded now by the accuracy in which you machine your block to these dimensions, so take your time. Don't get in a hurry. We're trying to instill good work habits early on. If you'll take the time to do that, you won't be disappointed. Okay, that's got a pretty clean surface. Now let's stop and take a measurement. Okay, we're 3 inches 980 thousandths. If you have the advantage of a digital readout, now's the time to reach up and let's zero that. We can quickly and efficiently peel off that additional 80 thousandths. It's going to be done in the x-axis now. Okay, we're going to take about 40 thousandths off in that pass. Climb cut another 12 coming across it. Okay, now we're going to want to kind of sneak up on this dimension a little bit. So let's take another climb cut at 65. Wipe the surface of our part down, make sure that we don't have any chips that may affect the accuracy of our measurement. We'll take another measurement with the dial calipers. Okay, we're 3 inches 916 thousandths. So at this point I'd reach up and simply re-zero my dial. Know that I want to take 16 thousandths off. So I'm going to go ahead and take another 6 on my pass across. Might as well take a little metal with you each time you go, even though it's in a climb cutting fashion. Go to 12. Then 16 on our last pass. And we're going to lock the table down. Here we go with a nice, smooth, uniform rotation of the hand wheel. Complete our finish pass, bringing our part to dimension. Loosen the gib, back our cutter away, we'll wipe our part down and okay, we're exactly 3 inches 900 thousandths on the money. Okay, we've completed the squaring operation. We've cut our part to dimension in 3 directions, thickness, width, and length. Now it's time to move on.
Attention, gun owners, collectors, hobby gunsmiths, FFL dealers, and professional gunsmiths. The American Gunsmithing Institute offers you comprehensive training and information through our exclusive instructional videos. AGI's complete line of how-to gunsmithing kits will give you the results you're looking for, whether you're refinishing a stock or glass bedding a rifle. Each kit comes complete with AGI-approved products and a video instruction manual featuring a master gunsmith. Whether the process is as simple as tactical spray coating or as involved as parkerizing, we guide you step by step as only AGI can, giving you the tips and techniques you need to avoid mistakes and get professional results. In the AGI Armorers series, each course covers a specific firearm. We give a brief overview of the history, demonstrate the design and function using cutaways, and guide you step by step through complete disassembly and reassembly down to the last part. We also show proper cleaning and lubrication methods, troubleshooting tips, repair techniques, and review available accessories. No other video will give you this level of instruction on one specific firearm. We offer courses on all the popular makes and models. Want to learn more about general gunsmithing techniques? In AGI's complete practical gunsmithing course, we show you how to set up your shop, and then we cover step by step the most common gunsmithing projects. In over 4 hours of exclusive video, a master gunsmith will teach you precision scope mounting, sight installation, stock repair, cold bluing, glass bedding, recoil pad installation, how to remove a dent from a shotgun barrel, and many other tricks of the trade. If you're interested in becoming a gunsmith, the American Gunsmithing Institute is internationally recognized for our professional gunsmithing course. It contains over 100 hours of detailed instruction on 56 videotapes. Instructor Robert H. Dunlap has over 30 years of professional gunsmithing experience and has taught professionally for 20 years at one of the nation's top gunsmithing schools. He will guide you step by step through the design, troubleshooting, and repair of all types of pistols, revolvers, shotguns, rifles, and .22s. Our close-up video techniques combined with Mr. Dunlap's exclusive knowledge and unique teaching methods provide you the opportunity to become an AGI-tested, certified gunsmith. Whatever your gunsmithing needs, AGI can provide you with the knowledge and materials you need to successfully customize, repair, and refinish your firearms. For a complete catalog featuring all of the AGI products, simply contact the American Gunsmithing Institute at 1325 Imola Avenue West, number 504, Napa, California 94559, or call 1-800-797-0867. Or you can browse through our color catalog with images from the actual videos at our website. Get online with the American Gunsmithing Institute at http://www.americangunsmith.com.